Yeah, thank you for the chat. It looks like I was talking away and I forgot to unmute myself. I kind of had this feeling I was going to forget something today, and I guess that was it. So shoot, I thought when the video stopped playing, it would unmute me automatically, and I didn't. I guess I didn't get that done. So hopefully everyone can hear me now. Yeah, thank you all for. Yeah, okay. Thank you all for for letting me know. Um, It's better than going the whole live stream without any audio. I don't think I've done that yet, but this wouldn't be the first time I started a stream on mute. So yeah, thank you for thank you for letting me know. I was just talking about the channel and some of the expectations here. When it comes to the Malware Mondays, the idea behind it, because you might be thinking, well, it's not Monday, it's Friday, and it is Friday. But the original idea was that I would post some artifact or some analysis objective on a Monday. I give everyone the week to work on that, and then Friday we'd review it as a group. Now, I found it a little bit difficult to keep up with that tempo over the course of launching this effort. So that doesn't mean that it's going to go away. It just means that this week was only a live stream, and we're going to talk today about basic file identification and hashing. And the whole idea with this series, to start at least, was it was kind of like going through a malware analysis course, just starting with basic topics. I did intend the videos to be something that you could start at, episode one and work your way through, or just pick episodes that have a very specific topic or tool that you want to learn. But if you have no, if you just want to learn malware analysis, start at the beginning, work your way through up to the current episode. And then as we get into 2025, I plan on continuing to expand upon that and likely starting to talk a little bit more advanced topics, which you'll also see, of course, in just one-offs in the channel itself. Okay, great. Glad to hear everyone can hear me okay. Thank you, everyone, for letting me know. Thanks for joining today. I don't know if I will get in any more live streams this year. It's possible I might do one more next week, but that would be the last chance, and it's looking less and less likely here. I do have some streams scheduled for January already, but as my luck would have it, I've gotten selected for jury duty in January, which adds a little bit of an unexpected element to my days. So hopefully that doesn't impact things too much. But I am a little hesitant to get too many things on the calendar just to get disrupted by jury duty. If you're not familiar with jury duty in the United States, it's part of our jury by trial system, and it's the duty of every citizen to go and at some point in their time, if not multiple times in their life, go and listen to some trials. So this will actually be my first, and I'm interested to see what the process will be like. Well, that's enough of that. I wasted too much time on mute. Let's get into today's topic here. I don't expect this to be a long stream, but who knows? It seems like every time I say that, then I end up talking forever. If you have questions along the way, please feel free to use the chat. I do get chat or comments from all the different sources that I'm streaming. So thank you from those of you joining LinkedIn, and YouTube seems to be really the most dominant at this point in time. I don't think I can post comments, but that'll direct to all the platforms. I think YouTube's actually the only thing that I can chat back to. So I'll try to answer everything live on air. If it's not directly related to what we're talking about, I might save it for the end and just try to go through anything that any questions or any discussion items that you have at the end there. Okay, so here you can see, wanted just to point out here before we get started, hopefully you can see my VM. I'm in a Flare VM. That's pretty much the only VM I'm using these days, both professionally at work and then I guess professionally outside of work here for streaming and stuff. So if you wanted to follow along the whole series of Flare VM, and I've got a video on the channel here that talks about installing the Flare VM if that's something that is new to you. A couple of things. The Lockbit series is complete. There's 9 videos, talk about many different anti-analysis techniques, and some core techniques here. For example, video 3, identifying signs of runtime linking. That's just a technique you'll see kind of across the board. So you'll see that in malware for dynamically resolving libraries and APIs. You'll see it definitely in shellcode. The latest series is a 5-video series on installing Suricata in the Flare VM, and then using that in combination with FakeNet to actually generate network-based alerts. And then the last video discusses the basics of writing custom rules. So that's definitely something to check out. If you didn't catch the live stream yesterday, Andy Wick joined. Andy is the creator of Archemy, which is just a phenomenal packet capture and packet analysis tool. So definitely consider checking that out. And then here's just the whole playlist with the Malware Mondays. So thanks to everyone who has joined. If you haven't considered being a member, please consider. You can go to the channel, click on join. You'll see different membership options. I am right now in the process of creating a, I don't know how many videos it's going to be yet. It'll be a few videos, but it'll be members only on creating the basics of creating custom shellcode. So hopefully I will have that all launched and ready to go here by next week. All right, let's enough of that here. Don't really need to be in the browser quite yet, although I will be spending some time on places like Malware Bazaar and VirusTotal. What I want to start with is here's a folder of different files that I just randomly grabbed from my system. You can ignore this DS store. That's just a silly Mac artifact from copying it over. So if you see that show up anywhere here with our analysis, feel free to ignore that. You can go to the site, cyberyeti.com, and download the zip. This should have pretty much everything, except I somehow forgot to add a handful of PE, just regular old PE files. So that'll be the only difference. But if you wanted to grab an archive here with these different files, then these are what I'm using for the stream. So you can find that on the Cyber Yeti. There's the Malware Mondays link up at the top. Now, the idea here is that I just wanted to collect sort of a grab bag of different files, different file types, so that we could go through some basic identification. Now, something that like every malware analyst and reverse engineer should tell you is that whenever they start doing analysis, they start with the basic techniques. That is, it's very rare that I grab a binary or I'm given a binary to analyze and I go right into IDA Pro and start reversing it. I usually start with basics. And of those basic techniques, then file identification is one of the first, because we need to be able to figure out the type of file that we're dealing with. Now, I have a couple of terminals open here. I'm in the Flare VM. I installed the Linux subsystem for Windows so that I could use this file utility in a bash environment. And the main reason I did that was just because it makes it a little bit easier to do some of the recursive searching that I'd like to perform with file. We have the file utility. Here's a PowerShell terminal. And you can see I'm just going to have these two tabs open to bounce back and forth between the two. We have the file utility here in just kind of, the Windows version here. And I guess I'm not even entirely sure where this utility comes from. My gut guess is that it's sysinternals, but I'm not 100% sure. It's installed by Choco and Chocolatey, so we could probably dig in and figure it out. But the problem is that I can't find a way to recursively use this file utility. So if anybody has a way to do that, that would be great. So we'll be using kind of both of these here. Let me just check something. Yeah, okay. All right, so we have our corpus, and what we can do here is let's just start with some basic. This is a new folder here for PE files. I'm gonna go into this folder, and I want to just do file star. This is kind of the thing that I'm missing inside of my Windows terminal, or at least I couldn't figure out how to do it. So I want to say file star to get all of the different files here. I can't do that, but I can list all of them explicitly, which I find to be kind of a pain. So file star, that's where we're going to start. File utility. Now, the file utility itself is a utility to help with file identification. It has a database or a signature file somewhere buried in the utility itself. I'm not entirely sure. I went looking for it at one point in time, but after about 15 minutes of searching, I didn't find the actual database or signature files that it uses. It's going to be able to look at different byte patterns within the files and try to detect. And that's typically what we're looking for when it comes to detecting files. We're looking for different sequences of bytes within the file, typically in the header, either the leading bytes or the leading bytes plus some specific offsets, to to try to determine what it is. Now, PE files are interesting in and of themselves because we have different types of executables or different considerations within the PE file itself. So we have 32-bit versus 64-bit. .NET files use the standard PE file format. We have like Golang binaries. They're still PE files, but if we detect the PE file that we're investigating as a Golang binary, right, then that kind of changes the approach. It changes and adds some considerations and typically some challenges to our analysis. So those are all really good things that we want to be able to recover as part of this file identification. Here you can see running file in this utility. I have a DLL. That is something that was actually malicious. We have this import tables. That's just something I was working on. And then this stage 4 rumcos, again, that was actually rumcos malware. Here are the different results. Right? So usually it's pretty obvious that we have a PE file because we have PE32, PE32 plus, and then the rest of the string here. And the PE32, PE32 plus, the difference between that, and you can kind of see it here in the remaining output, is that the PE32 would indicate a 32-bit file, as you can see here with this 8386, and PE32 plus would indicate a 64-bit file. And so that's also sort of indicative here, x86-64. So that helps, and it's very clear here that we're dealing with a PE file, a portable executable. Is this a Golang? I don't know. Is this .NET? Well, no, it's not .NET. And I can say that because if we navigate to the .NET folder and we'll do file star, you'll see the output looks a little bit different. That is, we have the PE32 to lead this output, but here we have the important mono, whoops, let me see, where's the button? Nope. I forget my annotation here, so I'll just use the arrow. We have the mono.NET assembly, right? And that's the indication here that we're dealing with a PE file that contains .NET code. Now, there are other indications. If we go poking around these file formats and look at things like different structures within the metadata, the header of the file, or different sections or imports, there's other ways we can determine that. But this is typically one of the easiest. So those are the two differences. Now, let's go to this Golang directory, right? I'll clear the screen here, list the contents. You can see there's a number of files. Now, some of these, unpack.bin, for example, that is a Golang binary that was originally packed with UPX. So when we're doing file detection, right, something that is packed, right, like this is probably the most traditional sense of packing, in that we have an original executable file, in this case that was written in Go, still a PE file, but then the entirety of the file is wrapped up and compressed inside of another binary using UPX. And so when we're detecting or doing any sort of analysis on this file, we can't really see anything or determine anything about the file that's contained within. All right, so we're only going to get file identification on the UPX. So UPX could be unmanaged code PE file, but then it unpacks a .NET binary, right, and executes that. So let's just run file star on this directory. And we'll see, okay, there's a bunch of PE32 plus PE32. So we got a combination of 32, 64-bit samples. At this point, that doesn't typically matter a whole lot to me. At least I can't think of a reason why I would generally care until I start reversing the code. And then it would just be that I'll be dealing with 64-bit versus 32-bit. And there's some like nuances in the low-level assembly and some different aspects of 64-bit code. Now, what about these files that I say are all actually Golang, or they're UPX packed and they contain Golang binaries? Well, there's sort of another layer here that we'll talk about, and that's using detected easy. So we'll come back to that in just a moment. So let's just put a pin on that. Okay, so those are well known. We talked about PE files. We talked about .NET. We'll come back to Golang. What about Mac? Let's see what I have in here. I have a zip, so I better extract that. Ocean Lotus. I don't remember where this came from. Okay, so 7-zip. All right, looks like we're going to have to move on over to our PowerShell terminal. I'm pretty sure 7-zip is in here. Right, what's the password? Oh, good. Password is infected. There you go. You can see it on the screen, hopefully. Hello from Twitch. Yeah, I decided last minute to stream to Twitch. I don't have much of a presence there. At least I haven't logged in or looked at my Twitch account in quite some time. So thanks for joining. Let's see. So now we have the file. We can actually just use file here between our PowerShell and our bash. You'll see that it is, oh, what did we get here? Another zip, really. I know maybe I forgot what this content is, and we'll have to skip it for the time being. Oh, yeah, no, that looks like some sort of a Mac file. Yeah, okay. I don't quite remember the internal structure here, but I guess maybe this is an opportunity where, when I come across a file type like this that I don't either recall or I don't understand, in this case, it's a zip file for what I have as a Mac. So my memory is failing me. I'd have to go to Google or a search engine or probably an LLM now and just try to do a little bit of research about file formats on a Mac. Now, let's just stay focused for a moment. Maybe this tool here will help. But we have the original zip file, and then we have another, what appears to be another zip container. So I'll run file on that again, and we'll see the output, zip archive. There's another tool here called Magika. And Magika is released by Google earlier this year. They have a good technical paper out there if you want to read about its approach. But the idea with Magika is that it's supposed to help better detect unstructured data, unstructured file formats. I don't think that's going to be the case here. I think it's probably going to tell me that this is a zip file. Yeah, it sure does. But we'll take a look at some other samples in a moment where Magika really does help out a lot. So let's back out of here. Let's see what else we got. There's some Java binaries. I threw a bunch of things in here just for experimentation. So I'm probably not going to get through all of it, but you have some opportunity there to play around. Let's go into the scripts folder, and you'll see that there is 3 files. The extensions here should be accurate, right? .js, and then an HTA file. Now, of course, when we're doing sort of one-off analysis, if I'm just analyzing a single artifact or I'm extracting different stages from, originally a single artifact, it isn't necessarily difficult to open those up and see what they are, right? I could open up this ostap demo.js. I could use a text editor. I could look at this and say, okay, well, this looks like JavaScript or JScript. The context does matter a little bit, right? So if I see this, say this is the second or third stage from an Office document or an attachment to an email, and it's going to be executed by C script or W script, like that context can help. But I can kind of look at it and see that it's JavaScript, at least some variation thereof. Now, what happens if I run file? Let's go back to our bash terminal, and we'll go to the script folder, and I'll say, here, let's clear the screen. I'm going to zoom this in a little bit, and then I'll go file start here, and you'll see that here's the 3 output options that we get. We have an HTML document. Okay, that kind of makes sense. The HTA docs usually have HTML elements in their content. We have this first stage.js that says this is ASCII text, and then this last one is just data. Even though we looked at the content, we saw clearly there that there's executable code. It looked like JavaScript. Data, in my experience, is just file's way of saying, I'm not really sure what this is. So it must just be data. Where does that leave us? Well, this is where, and now this is why I have to go back to my PowerShell terminal. We can use Magika, and I don't know if I can use the star. Yeah, I can. Awesome. And you'll see that the results here are a little bit better, right? So let's see if I can zoom this in and get most of it on the page. First, we have the HTA doc, and you can see that it recognizes that as Visual Basic Source. Yeah, that's probably true. It's probably VB script inside there for the HTA. We have the next 2 samples that it both accurately defines as JavaScript, right? So, in this case, I'd say it certainly did a better job of detecting the right kind of content in those files and was much more helpful than the file output utility. So that's really cool. Now, if we go back to the PE folder, right, and we run magika here, you'll see this is maybe a little less helpful. This is probably the one area, and I know several folks have stressed this or reported this to the magika team, where the PE file results is a little less helpful. It's great to know that this is a PE file, but as you saw with the previous file utility output, that was quite a bit more helpful. We were able to determine if it was a .NET binary. We were able to determine if it was 32 or 64-bit. Sometimes you can tell if a binary is stripped, which just means that symbols have been removed. Sometimes you'll even see information about packing. UPX is typically the one that I see here. So there's a lot of information that actually file can embed into the results that it gives. That in this case, just seeing the output from magika PE executable isn't quite as verbose or as helpful. So it has its areas where it's both great and maybe could use a little bit more love. We could look at .NET, for example, and you'll see if we run magika here, we're going to get the same kind of results, right? Even though these are .NET files, we couldn't determine that from magika's output. So, okay, are there other areas that we could explore? Yeah, right. So there's this whole folder, web shells and web panels as another example here. We could just take a look at those real quick. And these are a number of probably much older shells that I was able to find over the years. Actually been a little bit more challenging lately to find open web shells and other web shells. Doing directory crawling, open directories in particular, it's kind of great when whatever security product is on the server identifies a potentially malicious file and adds a .suspected extension to it, because that makes it downloadable. But here, if we run magika on this output, as you might expect now, we get pretty good results. Right? We have PHP files, which those are. We have an ASP file, which it certainly looks like it is by the extension, and usually because these come from a web server, the extensions are fairly accurate. And then a zip file, so just a panel that hasn't been extracted. If you extracted it, though, I'm pretty sure it's all PHP there. All right, last one here. We'll just do the same thing. Look at this content with file, and here we have, oh, it did pretty good, right? PHP script, zip archive. Okay, here maybe not so great. It just said that it was an HTML document, but quite similar. So it's just another tool. It's another way to potentially help with file identification, whether for your discrete investigations or maybe if you're doing something at scale. You'll notice when we get into VirusTotal, let's pull up a sample here. Well, we'll come back to it, but you'll see magika, because magika is included here in the output that we're going to get with VirusTotal. Okay, let's talk about other ways of identifying files. So I'm going to go back to the Golang, and I'm going to pick on this banload unpacked, or maybe this ransomware.bin. I don't know if it really matters. Just need a Golang binary that's not still packed. So Detected Easy is another great tool. If you're not using it, it is definitely worth checking out. Give me just 1 second here. I swapped VMs at the last moment, and font here. I think I just trying to figure out where to update. Yeah, there we go. Make the font size a little bit larger. Okay, maybe I need to close it. I think I'm one version behind here on this VM with Detected Easy. Yeah, there we go. Hopefully that's a little bit better. I should probably make that even larger. Appearance font, let's go 18. Okay. We'll restart one more time. Yeah, I think the latest version of Detected Easy, it applies it immediately. It's had a few noticeable UI changes. Let's see, version 3.09. Yeah, maybe this is. I'm going to check my other VM because if it is the difference here in versions, and we'll just download it. I probably could for the sake of time. Not. There's probably a quicker way to upgrade, but I'm not going to be able to think of it off the top of my head. So we'll just go GitHub, detect it. Easy. We'll download the latest release binary. We should be able to pull that right off the GitHub here. I think it's installed through Choco, so there's probably a way to, let's see, download releases. Yeah, there's probably a way to upgrade it through Choco, but here we go. 3.10, I'm on 309, so yeah, there's definitely an upgraded version here. Let's grab the 64-bit. And we'll just throw this on the desktop. Yeah, some comments. Yeah, if you you have 309, I think that was obviously the last version. So if you haven't updated or created a new Flare VM in a while, yeah, you just don't have the latest version. Yeah, Drew, thanks for joining. Drew from YouTube just said your ability to run your own Yara rules against the file. So we'll talk about the signatures, and that's probably the biggest thing here with Detect It Easy is our signatures. So let's get this open and we'll close this version. We'll extract the file here. Ooh, shoot. Yeah, I did that on the desktop. Okay, well, that's fine. Here we go. We can see that we've got 3.10 running now. Let's drop the ransomware.bin into the folder. Yeah, maybe I'll use this one. Okay, I think this is the one. Yeah, this is one I want. Okay, so we'll do that. Now I will go into the options and we'll update the fonts. As you can see, looks a little bit different in here. It's a little bit more granular as well. So we'll just, for the sake of completeness here, I'll bump up all the fonts. Sorry about doing this live here. I swapped VMs at the last minute, and there we go. Okay, so here you can see Detect It Easy, and latest version now, 3.10. You can see that up in the title bar here. I think that's probably the easiest place to recognize that. And this window is where, down in the lower left, is where it really prioritizes the signatures. And you get not just signatures to help detect code protectors and packers, but also, as you can see here, potential languages, maybe the compiler or the linker. And with this binary, now we're able to recognize, we're able to take kind of that original file utility output and take it one step further, because now there's signatures that allow us to detect this as a Go binary. And knowing that, we know things that will change possibly our analysis. For example, Go binaries tend to be quite large. Why is that? Well, because they include basically the entire runtime in the binary. So they have language features like .NET does and Java does, and that there is a runtime. There is things like managed code execution. There's garbage cleanup. There's just a number of things. But with like a .NET binary, that depends on the .NET runtime being installed in Windows, which it's a Microsoft thing, so they can kind of bundle those things together. Go can't really, well, they decided not to depend on that, not requiring folks to have a runtime installed or some other dependency. So it's all just sort of baked into the binary. Strings are another example. Strings are not null terminated. Strings are referenced in the code by an offset and the length. And so it makes string recovery a little bit harder. So like knowing those things can really help change the analysis as you start looking a little bit deeper into the binary. One thing that I think is kind of interesting here, we have signatures down below. You also have, let's see, where is that? There's a, it's changed a little bit, but yeah, here we go. You also now have, as Drew pointed out, the ability to scan with Yara rules, right? So you can have a your own Yara rules, or you can add Yara rules that are from the community, however you'd like to do that. If you go with the default here, Detected Easy has its own signature database. And so down here in the lower left, you can click on signatures. And this will bring up the signature dialog. We can start searching. So you can see it's organized by file type. So we have PE file. So if we type in Go, there's the Go signatures. And you can see here that this is the sort of the custom implementation of signatures. Looks, similar to other signature type, formats that are out there. But this is Detected Easy's version of it. So all right, one of the first things it does, it checks if the section has the .symtab section, and that's a Golang thing. And then it does some additional detection here. And there's a lot of conditional logic. There's a series of if, else, if statements where it's comparing a sequence of bytes at the entry point. And those sequence of bytes represent code. So somebody took the time to look at those leading bytes and said, okay, this is a reliable pattern to determine these Go binaries. Now, something that I found really cool here, let's go back to the main. Okay, I'll close this, I guess. You can see that it detected the languages Go, and it said this is Go 1.7x to 1.9x. And if we go back to those signatures, I guess we could probably figure it out, right? 1.7x to 1.9x, so it must have matched on this particular part of the rule. But sometimes these can get complicated, or it might just be easier. You can actually debug these. So this is something that I hadn't played with much until just the other day. If you click on debug, this will bring up a little debug thing, and it's going to debug based off of the signature that matched. And you'll have up above here your basic debug commands: step in, step out, step over. And so we can just start stepping through this code. And you'll see the first thing that it does, hits this first conditional, and it does actually contain that symtab section. So it's not going to enter. Therefore, it has to go into this branch, and now it's looking for code patterns. So basically it's saying if it's a Go binary, it's going to have the symtab section name. Otherwise, it's going to look at these different code patterns. And here you can see, now we know exactly what path it went. We can continue to step. And there's some additional checking here. So you will see with newer binaries, they will have version information. And so this is just where it's checking. So sometimes when you look at Detected Easy results, it might give you an exact version. And that's because it was able to find it based off of some other Golang internals. But in this case, it's not going to find that. And so it just says, all right, Go detected, it's this version range based off of the entry point code. And there you go. So if you look at these, because they are, right, they're kind of, there's a little bit more here than like a simple Yara. Well, there's a little bit more here than just like a Yara. Yara, you have to apply patterns using basic Boolean logic, where here you can have a little bit more of this conditional logic. So just thought that was neat, pointing out if you're working with Detected Easy and need to kind of really understand what these signatures are telling you. Yeah, cool. Thanks, Drew. I'm glad somebody else thought that was neat too. I thought that was really cool. Okay, so that's it. Other signatures, they'll show up here, right? Anything that matches will show up here. You'll have the ability to dig into your signatures. And then, of course, with a tool like Detected Easy, you've got all this other stuff to help with your initial analysis, right? So oftentimes with a binary, I might skip file and go right to something like Detected Easy. Now, the last thing that we can talk about is just some basic Yara stuff. And this is a file you'll see really large, a lot of rules in here. But I just plucked this morning off of a GitHub from Manalyze, and I have no idea what this is. So this isn't, I don't mean to, I just have no idea, right? So I'm just using it because this fit the bill in terms of what I was looking for. As an example, then, we just have a bunch of basic Yara rules here that are there to help determine file types. And as you'll see, typically what they're doing is they're defining strings. They probably don't need to define the string. This could just have been a condition, but just a sequence of bytes, and then the condition in which those bytes should match. And you can go through these to see the different file type identification. It's probably going to be not quite as good as things like file, but it is there, and it is just a way or an application of using Yara. So let's go to the directory where I have that Yara rule. What did I call that? Magic. And we'll just look at the PE files. Tac R will give us recursive, right? And so there we go. That just is telling us, kind of like magika in this case, hey, you've got 3 executable files in this directory. We could look at executable files, so that's the name of the rule. We could go back to our Yara rule, executable file here, and here, let's put a space in front of that. And there's the there's the rule itself, right? And this is a pretty common pattern here, in that it looks for the first 2 bytes of the PE file. So at offset 0, it looks for 45A, and then from there, it uses LFA new, which is the member at the beginning of the file, the image DOS header, that navigates to the next section, which is PE, the uppercase P, uppercase E, followed by 2 null bytes. And that's just what this hex sequence here represents, right? So this can be kind of helpful, especially if you're not really sure, like how do under the hood does file identification work? Well, like this can be a helpful way of looking at those byte patterns, and maybe getting a little bit better understanding. Of course, there's a lot of documentation scattered across the internet, right? So if you really get interested in looking at file identification, right, then that's something you can do. One word of caution here is you'll notice, for example, a rule like this, and I'm not entirely sure how file works, but let's say that you have, a PE file, but it comes from a memory dump. So maybe the PE file isn't at the beginning of that memory dump, or maybe you have a PCAP, and the PCAP might contain content that you're searching for. Well, this rule here is looking at the beginning. uint 16.0 says look at the beginning, offset 0, byte 0 of the file to look for this pattern, right? And so if that pattern is 1 byte off or further in the content, or maybe you're looking at a memory dump with a lot of PE files, you have to take a different approach to identifying those, right? Same with identifying additional content in PCAPs. Right? You have to be able to search throughout the content of the file in a reliable way. So there is oftentimes some caveats with that file identification detection, and understanding sort of where it came from can be helpful. Am I dealing with, and typically for me, the biggest thing is, am I dealing with a memory dump, or is this the actual file itself? Okay, yeah, question from YouTube from Hex Coffee. Should I watch Malware Mondays from 01? Yeah, so it started the stream in mute, talking about that. But the idea with these is it's like a basic series and everything. I'm trying to keep them connected and that they're flowing. So I'm kind of like creating a mini class here where we don't hold class regularly. So yes, if you wanted to start at the beginning, most of the content then should build up, and it should help with some basics. Oh, thanks. Yeah, thanks, Sean. I'm glad for the comment that you'll love to watch them. So, especially ones with audio. Okay, so what are some other things we can talk about? And keep in mind, like when we talk about file identification, or anything, there are so many different avenues we could go down. Like I'm focusing on one aspect of it, but file identification itself, there's so many different caveats and niche areas and considerations. So we're just trying to cover the basics here. All right, so using a tool like Die, that's oftentimes the place where I begin, because I get not only the file type, but also this additional insight into the binary. If you're curious, how did it detect that? Look at the signatures tab. That'll help you out, right? That'll tell you exactly how it's doing it. If you have trouble interpreting a signature, try debugging it, because then you can actually step through the logic as it matches your file. Okay, another thing that we will oftentimes need to do is to create hashes. Hashes are one-way cryptographic algorithms. That is, it takes an input, a chunk of bytes, it runs through the algorithm, it produces a hash value. And that hash value, it's very, very difficult, if not impossible, to take the hash value and go in the reverse direction. We can't take the hash and then recover the original content that was used to generate that hash. That's why they're considered one way. Other cryptographic algorithms that are designed to provide for that two-way, that is to take plain text, turn it into ciphertext, and then be able to recover that ciphertext back into plain text, right? That's a different category. These, when it comes to hashing algorithms, SHA-256 or SHA-256 and MD5 are still the two most prevalent. MD5 is a bit older. There's some weaknesses and sort of vulnerabilities in it. But when it comes to identifying files, it's still pretty solid. It really doesn't matter. What you choose is up to you. You'll find that most platforms will support either. That is, if I go to VirusTotal and I want to search, or if I go to Malware Bazaar and I want to search for something, I can search based off of the hash, whether it's the MD5 or the SHA-2. MD5s are a little bit shorter. So let's just look at getting hashes of a file. So we'll say get file hash. This is in PowerShell. We have to define the algorithm. So we can say MD5. Let's go. I want to go pick a very specific example here. Let's do the Remcos one. Okay, so we'll say get file hash, algo MD5, or you could say SHA-256, and then our file. And now we have our hash, right? So there's our MD5. We can copy that, and now that is a way to represent that file in a way where oftentimes I'm going to use it to search places like VirusTotal to gather intelligence. What do we know about the file? If it's not on VirusTotal yet, well, then I know it's something that's undiscovered. There's something unique and interesting about that. If it's on VirusTotal, then hopefully we have a lot of insight here. I'm not going to spend a lot of time on VirusTotal because I have a previous stream where we went into online tools such as VirusTotal and online sandboxes. If we go to the details tab, though, you can see there is this basic properties. And here we have, as I was mentioning, all of the different hashes. And these hashes, so the way that we're talking about hashing now is the entirety of the file, right? From the beginning to the end, let's take all of those bytes and create a hash. And that's very common because it lets us identify that file. I can look up the file on places like VirusTotal. I can share this hash with you now, or you can copy it off the screen. I know that would be painful, but like you can now reference the same file without me having to share that file with you. So that's the greatness about it. The challenge is that if a single bit changes in the input, then that changes the output hash, right? And so malware authors know this, and they use hash busting techniques. They use techniques in order to take the same file, but modify a byte here or there, modify a bit here or there. Bytes are easier to modify, so that way it changes the hash, and it makes it harder because now we have to track all of these discrete samples that are essentially the same thing. Here we can see file type, and there's our, I think magika. I don't know. I know magika's in here. Maybe I'm just staring right at it, but this is an older sample too. Maybe it's only on newer samples that it's adding the magika output, or it's going back and adding it and it's just taking a while. I don't know. VirusTotal has a lot of malware, so I could see where they might draw the line and say, only on these newer samples, since we've added the technology this year, will we provide that output. But you will see magika output. There are other hashes too, which I probably we'll talk a little bit about, like the import hash. But there are other hashes, right? We can take other aspects of a file and just hash that portion of it, and then try to use that not only for identification but for discovery. The rich header is an example in which the rich header is part of a PE file. Not all PE files, but can be part of a PE file. It just contains information about the build environment if it's compiled using Visual Studio. You could take all of that content and hash it. And turns out that can be an indicator to identify other samples. If you want a really interesting use case, I believe Olympic Destroyer. Boy, if I could type today, Olympic Destroyer rich header. Here, I'll share this in the chat too. Yeah, here we go. So here's just a kind of an interesting story from I think the Olympics that were held in South Korea a couple years ago. maybe several years ago. Maybe this isn't it. I'll try to look this up now. Yeah, that was it. So, anyways, if you look up the Olympic destroyer and the rich header, how rich headers were used in that investigation, it's a pretty interesting read. I'm pretty sure this is it. So I'll share this in the chat. But anyways, my whole point of that is that there are different ways in which we can look at the content and create hashes. It doesn't have to be the entirety of the file. And so these rich header hashes, the import hash, we can hash sections. There's just different ways in which we can do that. There's other algorithms as well, like SSDeep, that tries to account for these slight variations and be able to take files or a large corpus of files, or I guess a small corpus of files, and say, yeah, you know what, they're not the same hashes, but they're close. They're 99%, they're 80% related. And so many different tools out there that can help with that. I just don't find it's been years since I've used SSDeep in a meaningful way, right? So I don't know if that's saying anything to anyone, but it's just not something that I use that often. So here we have, again, sort of the easy way to generate these hashes. We could use SHA-256. You can see here we just get a larger hash. I just typically look at the last few bytes here, 5682. And if we go to the details, here's the SHA-256, 5682. All right, so it looks like, of course, as you would expect, those would match up. So they can be kind of interchangeable in terms of when we're looking this up. A lot of these online platforms support multiple versions. Now, if we go back to the terminal and we go to bash, we'll go to the PE file folder here. Here you have SHA-SUM. There's, I think, more than one utility here where we can define the algorithm. And there's our hash, right, 5682, and MD5 sum. Same thing here. Okay, so however you generate those hashes, tools like Detected Easy. Here we're going to turn on the advanced mode. Let's see, I think hash is where we're going to have different hashes. And you can see that not only is it going to give us, let's see, 6F37, D5 sum, D4F9. So is that? Oh, I'm looking at a different sample here. So let's just swap that out. Hopefully I can just drag and drop. So we'll go to the PE folder and drop this file in here. And then look at the hash, D4F9. Yep, there it is. All right, we have not only the overall hash, but now there's hashes of different parts of the file, the sections, the header, and other ways of looking at it, right? So my main point here is just that creating hashes doesn't necessarily need to be, and isn't always, it doesn't necessarily need to be just the file itself. There's other useful applications. Now, this is one way to get the hash information, right? We can use tools like DI to generate it. Now we can use that hash in a Yara rule, for example, or to search online. Another opportunity here is to actually use Yara. And this is something where if you're familiar with Yara, but maybe not familiar with the console module, when I first started using Yara, I thought, why would you ever need a console module in Yara? Well, it turns out the console module can be pretty helpful. What does the console do? Well, as the name suggests, it logs information to your console. So let's look at this first rule as an example here. We have just a condition, and I'm going to say console.log, and we'll use the PE module to just get the import hash. Now, this will allow us then to essentially, or to leverage Yara to generate the import hash for us, and then we'll just print it. So it's like it's our ability to recover it. The other way of using the import hash, so let's first just generate it. I'm going to go back to PowerShell. Yara, need to go back a directory. Yara, hashing, and let's see, PE, stage 4. I want to stick with my Remco sample. All right, there's the import hash. So now that we've generated the import hash, we can copy that, and now we could actually use it in a rule to look for samples or detect samples that match that. So we could say something like pe.imp hash equals, right? We get rid of this part right here. Right? So we can use Yara to recover the information, and then we can make another rule to actually detect it. So kind of a cool, I think a cool use of the console.log. I hadn't been using it until I had a colleague show me several examples like this. It just was I think really helpful. What can we do with the import hash? Well, you can look up the actual how the import hash is created. I've actually forgotten the details over the years, but essentially the type, the number of imports, this all has to do with imported libraries. So if we go back to Detected Easy, for example, you can look at the imports right here, right? And imports tell us a lot, right? I think I did a stream on imports, so I won't spend a lot of time. But we have, make this large, we have the primary library, kernel 32, user 32, and then we can see the actual imported files here. And so you can, the idea is that this can sometimes be in a unique enough order, that is between the module and then the actual API, that if that information is hashed, it can be used to detect related samples, because there is some uniqueness in how maybe the libraries and the APIs were imported. So that's what that import hash can provide. And so here with a Yara, we can recover that import hash as you just saw. And then we can go to places. I'm going to pivot over to the Malware Bazaar. And the reason that I'm doing that is because, unfortunately, outside of work, I don't have a VirusTotal account. And being able to search based off of the import hash requires a premium account. Malware Bazaar does not require that. So we can go to the Malware Bazaar. This is an abuse.ch project. If you're not familiar with abuse.ch, definitely go there, check it out. They're doing awesome work. But we can just type in the keyword imp hash and then our hash. And now this will bring up all of the related samples, any sample that matches the import hash. And you'll see that that is Remcos, and we have a lot of Remcos samples that have matched over the years. A lot of 2022, some 2024 though, and even some really recent stuff. Right. So again, just an example that might be able to use that hash to detect related samples, or maybe you found something, you don't know anything about it. You take the import hash, you come to Malware Bazaar, and you go, oh, well, here's I don't know if it gives me a count. Here's 83 items that are all tagged as Remcos that match my sample. So maybe it's Remcos. So let's see. Yes, good afternoon, Hannah probably, and casually Joseph. Thanks for joining. It is almost noon here. Not quite. I'm Central Time. We have been in the single and negative digits Fahrenheit though here, so it's been quite cold. Okay, let's see. I'm getting kind of long, as I said. I always do that. Let's look at one more example, and this is just a rule to hash the sections. All right, so let's start real quick by exploring these in Detected Easy. I'm going to go back to a Golang binary. We'll pick ban load unpacked. Yep, that looks good. So we'll run this. Here we have, okay, detected Golang. Yep, this is the same sample. You can look at the memory map. And the memory map here is just a way to look at sections. Sections just contain things. Sections contain executable code. They contain global data. They contain resources. Well, with Golang binaries, they will oftentimes contain a .sim tab. And that contains that's a section that contains structures for the Golang binary, particularly to help with runtime stuff. So that sim tab section as we've already seen, can be one way in which a rule might simply detect its Golang. In fact, when we looked at the signature here in die, it was saying if it doesn't have it, then let's get more precise, because I was like saying if it doesn't have it, then, or if it doesn't have it, then we've got to do some additional checking. If it does have it, well, then we know it's Golang, so let's try to determine the version number. I'm just using this as an example because now in this section hashes, right, we can say something like, let's make sure that our file actually has sections, right? There's some basic Yara rule considerations here for performance and other things that you might want to do. I'm kind of ignoring those for now. Do you want to make sure it's a PE file? Do you want to make sure it has a number of sections? The things that you might want to check before you start doing the more expensive checks. And if you weren't familiar, right, inside a condition, there really is no such thing as an order of precedence here. Like Yara starts to evaluate conditions left to right, so the things that are most likely to be false should be put first. And that can help performance then. The things that are more expensive, we put right. Now, if I'm just running this on a small set of samples in my analysis VM, I don't really care. If I'm taking this rule though and I'm deploying it to a production setting and it's going to run against thousands of samples daily, then I care. So here though, the gist of what I'm after is just to show that we can actually hash the section names or the section data. Right? We can really kind of pick whatever we want, right? And create a hash of it. But a section hash would make sense. Maybe not a Golang section hash or the SymTab section hash, but that's just an example. And so what I'm doing in this loop is saying, okay, as we're iterating through the sections, maybe we'll change this to text, right? If the name of the section is text, or whatever you want to put here, then I want to print the name of the section just to confirm, or just to show another use of console.log. And then I want to use the console.log to print the hash. And here we're using the hash module, so hash.sha256. And all we need are where to begin and then where to end, or the length. So here you have properties of the sections. So the section at the index, if it matches the name.text, raw data offset, and then raw data size. And you can see this. Let's see if I can find it here. Section. Everyone does things a little different here. Okay, so here we have the section information and detected easy. And you'll notice up above here, we have these different properties. We have virtual size, virtual address, raw, pointer to raw, size of raw data. And essentially what those properties, and those are exposed in Yara, what those properties are telling us is that the raw data, the raw pointer, is the section on disk. The virtual size, the virtual address, is the section in memory. And when a PE file, in this example, gets loaded by the operating system into memory, on disk, it stores those sections at the raw offsets and the raw size, and then in memory, it uses those virtual. And so there's a difference. So if we are scanning a PE file that has come from disk, that's where we would use these raw, right? Raw data offset, raw data size. Okay, so now let's save this rule and let's see what happens. We should be able to run this against anything that has a .text section. And here we go, right? Section name .text, section hash. Okay, so now that just hashed the section .text based off of the raw offset, raw size, and that's the hash of it. So now we could do some correlation or some searching or some hunting or whatever we want to do using the hash of that particular section. Right. So again, there's just many ways in which we can grab that hash information, and Yara is just one way. We can use it not only for detection, but we can use it, in this case, I was thinking about it like outside of detected easy. I don't know how else I would have, like Yara was the first thing that actually came to my mind. We'll just say, how could I get the hash of a particular section out of a PE file? Yeah, you've got like the PE file module and some other command line stuff, but I already had Yara rules that I was able to repurpose. So this was just a quick way, and hopefully an interesting way of using Yara for not just detection. It actually be used to help us with, the kind of this further identification and then the generation extraction of data that we can use. We could plug that right back into a Yara rule if we wanted to, right? Instead of saying console.log, we could just say generate the hash, and then do a comparison. Right? This wouldn't be syntactically accurate, but hopefully you get the idea here as I could turn around and kind of plug it back in, and now we could detect using Yara any file that has that. Okay, let's see. Any questions here? Are you using AA Arch 64 Mac? I don't know. I'm using an old trash can Mac Pro from 2013 or 14. So I have not ventured into the new world of Apple Silicon yet. In fact, that's actually been holding me back from upgrading. I have an older laptop as well that I am hanging on to for dear life because I just use VMs too much. And I actually I am a Mac person. I enjoy working on Macs. I think they're way overpriced, but that's a whole nother conversation. So I'm really holding out the upgrade here. Although this system is getting, it's getting, I don't know, I'm starting to have more and more issues. So I'm growing more concerned by the day that my forced upgrade will be happening sooner rather than later. Okay, so that's kind of it, right? File identification and hashing. That was the basic stuff I wanted to talk about. We really spent some time just talking about file utility, a little bit with Magika, doing a little bit with Yara, and then using tools like Detected Easy. There are plenty of tools that are going to be, PE files just happen to be, I think, the most prevalent because there's so much malware that is designed for Windows. But there are other tools that will help with file identification when it comes to, for example, like .NET. If we start poking around .NET binaries, I think a really great tool for this, although it's just not one that I've used, right? So it's just not typically part of my workflow unless I have a very specific reason. But CFF Explorer, where are you, CFF Explorer? No, it's not in my quick. I don't know why that's not there. Oh, because of the file extension. No, it should have been there. Well, anyways, it was in the launcher down below, so we'll open it up, and it does really, I think, really good with parsing .NET stuff, right? How often do I find myself digging around in the internals here? Well, not too often, but when I do have a need to get into the internals of like how the internals of the .NET structures, CFF Explorer is really good for that. In fact, I don't even know how much a tool like Detected Easy would expose here. Probably quite a bit. Right? It does a great job detecting and telling me all of the practical stuff I need to know. But if we go to the memory map, maybe there's a .NET section. Yeah, okay. So it looks like a lot of the same information is here as well, right? So I could probably use this equally as well as CFF Explorer. So I guess another win for Detected Easy because I've just never looked, and a lot of great stuff here. So you just got to check your tool, right? A lot of different options are out there, but we need to understand like where we're headed with the content, because detecting the file format, detecting things like is it a Golang, will help determine those next steps. I guess there is one last thing we can talk about, is just shellcode. I think shellcode is quite interesting. I have a directory here with just 3 different samples. Let's see what Magika does with detection here. Yeah, that's a directory. I knew that. Let me see. Do I do star? Yeah, there we go. ISO CD-ROM file system. Ooh, no, that's not right. Let's try file. Shellcode star. Data. Yeah, okay. So both of them here seem to struggle a little bit. And that's really understandable, because if you're not real familiar with shellcode, I'm just going to grab, I guess it doesn't really matter. I'm just going to grab one of these with a hex editor. The idea with shellcode is that we have content here that is designed to be, loaded into memory. However, right? Like you might often you'll hear a lot of times shellcode related to exploitation, because the shellcode will then be used after the thing is exploited to be put in memory and executed, and that's where the attacker gains control. But malware uses shellcode all the time, and there's no exploitation involved. It's just using it as a layer of making it harder to analyze or to modularize their code, or maybe it's the shell code that's doing decryption, deobfuscation, unpacking of the binary, as any number of things. But it's just a blob of executable code that is meant to be put into memory and executed directly by the CPU. So there is no file format per se, right? Because it's just going to be put into memory and executed directly. So that's why oftentimes it's hard to get any sort of file identification here, because there's just nothing. There is no headers. There is no metadata. It's all just code, and then anything else that the shellcode authors need, maybe some strings or some additional resources. If we compare this to, for example, I'll just open up a PE file real quick for reference. There's our DLL. Right here we have that header information. We have consistent patterns within the PE file because the operating system then is responsible for identification, parsing, and that tells it essentially how to load it into memory and then where to begin execution. So shellcode doesn't have that. So, and there's other, and that applies to other file formats. And then you get into like scripting languages where they don't have like a real rigid structure, but usually the language syntax and some of the constructs there we can use to represent. Like we can look at it as human beings and go, oh, I recognize this is PHP. Oh, I recognize this. This is VBA or JScript or something. Let's see. Questions from Casually Joseph. Section hashing is useful for protecting blocks of code instead of the full PE. Yeah, I mean, it's whatever is in that section. You might find that a section, predominantly it's going to be code. So in that case, if you're creating a hash of a section, as I did, I created a hash of a text section. Well, that's the code. So I'm using that to detect the entirety of the block. How helpful is that? I don't actually know. I've never used a hash of the text section for any useful thing. I've just never thought about it, never used them. So I'm not saying that it's useful, but I'm not saying that it isn't either. I've never really used it. I just used that as an example. There may be other sections though that contain arbitrary data, encrypted data, resources, configuration data. Maybe there is something that is a bit more consistent or reliable to create that hash and do some checking. So it's really up to you. It was just meant to be kind of a discussion point to show that hashes can be applied beyond just the just the entirety of the file itself. Import hashes is another example. We have on the network side of things, we have things like JA3 and JA4. That's hashing information from the establishment of a TLS session. And so that can be useful to identify related malware or command and control nodes or servers based off of the TLS session without being able to look into the encrypted traffic. And the rich header and the hashing of the rich header, right? Like that's a little spot where that actually kind of makes sense to create a hash of that and use that for maybe hunting or some detection. So just a lot of options when it comes to hashing. But for the most part, my day in and day out usage of hashing is to identify the sample itself. To say, okay, I've received a sample. Right? Like one of the first things I'll do, at work, we get tickets. Tickets will contain samples requesting analysis. And once I download that sample, the first thing I do is hash it and compare it to what the original reporter asked for, the hash they provided. I just want to make sure that the two samples match. I use them for archival purposes, right? I use them for labs. if I give you a lab, or like it's common convention whenever someone writes a blog or shares some samples to say, okay, like here's the hash of the thing I'm going to analyze. So if you want to follow along, you can go grab it. Hopefully it's on a place that allows you to download, such as the Malware Bazaar. Oh, goodness. Yeah. So I went plenty long today. Any other questions? Because I think this is certainly all I wanted to cover today. Okay, well, if there are no questions, hope everyone enjoyed the Malware Mondays. I do actually have a list of topics, so I'm going to continue to work on these into 2025, and as well as other live streams and other content on YouTube. So hopefully 2025 will be a big year for that. Yeah, thank you from Twitter. That was great. I really appreciate that. Yeah, these are yeah, Drew. So Drew brings up a good point. He brings this up often, and that a lot of times these streams, it's part to talk about reversing basics of malware analysis. The other part is to talk through workflow, and how I typically think through different problems and different analysis tasks, for better or for worse, right? Sometimes I know my approach isn't always the best, but I try to caveat that. Like when I don't, the Mac malware earlier, I just don't look at Mac stuff. And so off the top of my head, I couldn't quite remember what to do with it or what to expect when I got that zip archive. It's not hard to research. It's just something that I just don't deal with enough, so I just don't have it off the top of my head. Yeah, if you have suggestions for the stream, don't hesitate to send me a message. Let me know, whether it's for the Malware Mondays and topics you'd like to cover, or it's for the live streams and guests that you'd like to see come on. Because the guests, I really like to focus on something that they're working on, research they've done, tools they've created. And so it's just an opportunity to hopefully help promote that and highlight that. And usually there's something interesting there. Okay, well, I think that's going to be it then. I'm going to hit the end button here in just a moment. Happy New Year to everyone. If I don't stream before the end of the year, again, we'll start things off right though in 25. And if there's anything I can do in the meantime, don't hesitate to reach out. I am excited. I do have a new camera. The only thing I'm waiting on is a lens that should be delivered today. So I was hoping to stream today and try it out, but alas, I ordered it during a very busy time of the year. So it's en route. So hopefully I've got a lot of new stuff here going into the new year. Okay, my rambly sensors are going off. Happy New Year, everyone. Happy holidays. Merry Christmas. Talk to you all in the new year. Thanks for joining.